Hey, welcome back, students. In this lesson, we want to focus on showing you how to derive Graham's law. And keep in mind that this is what Graham's law is. Let me go ahead and write the equation for you just so that you know exactly what we're going to work towards, and then you can see how we can derive this mathematically. Graham's law essentially deals with looking at the relationship between velocity of a particle and its mass. And this is the equation here. So we've got the velocity of the first particle. It's going to be divided by the velocity of the second particle, and this is going to be equal to the square root of the mass of the second particle divided by the mass of the first. And so let's show you how we actually got this. And essentially what we're saying is if we have two particles, let's say we have one particle here, particle 1, and we have another particle 2 here, and they're going this way and another one's going that way. And essentially the reason we want to use Graham's law is because we want to see which one of these two particles is going to effuse faster out of a container than the other one. And so remember, effusion is essentially when you have two particles inside a container and they happen to escape through a little pinhole that are hole in the container itself. And so let's just go ahead and seal this up so there's no misunderstandings that this is actually a closed container. And so the pinhole is essentially here where the arrow is. And so we're asking which of these two particles is going to escape faster? Which one's going to have the faster rate of effusion? And so all of this begins with looking at each particle. And we know that one particle is going to have a kinetic energy that is equal to 1/2 mass times velocity squared. And the same is true of the other particles. So I can say Ke is equal to 1/2 mass times velocity squared for the second particle. And so since both of these are equal to the kinetic energy, what we can say is we can take this particular part of the equation and kind of go ahead and apply it here. And we're just going to move it down. And so what we've got is 1/2 mass times velocity squared. And we're going to go ahead and designate this with a little 1 to represent the first particle on both of these. And this is going to be equal to the other part of the equation for the second particle, okay, which is 1/2 mv squared. And again, this is for the second particle, so we're going to put a little 2 in the base for subscript, and this is essentially just comes down from there. Since both of these are the same, what we're doing is we're saying, okay, so we've got the velocities of these, we've got the mass, we're going to go ahead and multiply these by 2 on both sides. So we're going to multiply this one by 2, and we're going to multiply this side by 2. And when we do that, what happens is that the 2 cancels with the half, and the same thing over here. The half will cancel with a 2. And what we're left with is the following. m1 times the velocity of the first one squared is equal to m2 times the velocity of the second one squared. And so we want to get the velocities by themselves on the left-hand side and the masses on the right-hand side. What we'll do is we're going to divide on the right-hand side, we're going to divide by the velocity squared of the second variable. And on the right-hand side, we're going to go ahead and divide by the same number, so velocity squared of the second variable. And at the same time, what happens here is that on the right-hand side, the velocity is going to cancel out. And we're going to repeat the same thing for the m, because we want to get the m on the right-hand side. So we're going to go ahead and divide by m1 on the left-hand side. That cancels those variables there. And we bring it over to the right-hand side. So the overall end equation that we've got here is essentially the following. I'm going to go ahead and start this on another page just so that we can clear things up. But essentially what we've got is the following. So if we start this on the second window here, we're going to go ahead and do this now. We're going to go to the next one. So we'll have, and so essentially what we've got here is going to be the velocity of the first one squared divided by the velocity of the second particle squared equal to the mass of the second divided by the mass of the first. And so what we want to do is eliminate the squaring on the left-hand side. So we're going to take the square root. And when we do that, we'd have to do the same thing to the other side. So we'll take the square root of the right-hand side as well. When we take a square root of a squared variable like v1 and v2, what that winds up doing is cancels the square root as well as the squares, leaving us with the following. The velocity of the first variable divided by the velocity of the second variable. This is going to be equal to the square root of the second divided by the mass of the first. And this here is Graham's law. Okay? And so this is the equation you want to use when you're solving problems for this type of equation or sample set.